The first marketed soft drinks appeared in the 17th century. They were made from water and lemon juice sweetened with honey. The first drinkable man-made glass of carbonated water was created by Englishman Dr. Joseph Priestley in 1767. 3 years later, Swedish chemist Torbjörn Bergman invented a generating apparatus that made carbonated water from chalk by the use of sulfuric acid. Bergman's apparatus allowed imitation mineral water to be produced in large amounts. The drinking of either natural or artificial mineral water was considered a healthy practice. The American pharmacists selling mineral waters began to add medicinal and flavorful herbs to unflavored mineral water. They used birch bark, dandelion, and fruit extracts. Early American pharmacies with soda fountains became a popular part of culture. The goal of this study is to determine the effect of personal health choices on dental hygiene. Soft drinks are carbonated beverages that are popular among children and adults. Consumption of sodas has immediate and long-range effects on our personal health. Soda contains several types of acids, which may include phosphoric, carbonic, citric, tartaric, and malic acids. These acids cause the enamel to weaken, and prolonged exposure can lead to significant enamel loss on the teeth. Coca-Cola is one of the common brand of soda. This particular brand has a pH of 2.5, which makes them highly corrosive and detrimental to the tooth structure. Teeth are composed of calcium-deficient carbonated hydroxyapatite, which is why they are vulnerable to decalcification in acid media. Volumetric analysis. 3 aliquots were taken from each soda sample and placed into an Erlenmeyer flask. 5 ml of ammonia buffer and 3 to 4 drops stalagmite indicator were added. 3 ml of Coca-Cola sample was diluted in a 100 ml volumetric flask. 50 ml of this diluted Coke solution was titrated with EDTA. Gravimetric analysis. Remaining portions of solutions were reacted with ammonium oxalate. After samples began to boil, urea was added. Ammonium oxalate was then added. Solutions were heated for 30 minutes, allowing for precipitation. Solutions were vacuum filtrated. Samples were allowed to dry for 24 hours at 120 degrees Celsius. The calcium in a 100 ml sample of a natural water was determined by precipitating the cation as calcium oxalate. The precipitate was filtered, washed, and ignited in a crucible with an empty mass of 25.7868 grams. The mass of the crucible plus calcium oxide was 25.9234 grams. Calculate the concentration of calcium in water in units of grams per 100 ml of water. Solution. The mass of calcium oxide is 0.1366 grams. The number of moles of calcium in the sample is equal to the number of moles of calcium oxide. The mass of calcium oxide divided by its molecular mass times its stoichiometric factor is equal to 2.4359 times 10 raised to negative 3 mole of calcium. Concentration of calcium is equal to the mole of calcium multiplied by its molecular mass divided by the volume of the sample times 100 over 100. You'll get 0.09763 grams per 100 ml sample. Consider the titration of 20 ml of 0.02 molar calcium with 0.04 molar EDTA. Calculate the initial PCA. Calculate the PCA after addition of 2.5 ml of EDTA. Initial point. PCA is equals to negative log of the concentration of calcium, which is negative log of 0.02 molar. PCA for the initial point is 1.699. After addition of 2.5 ml of EDTA, PCA is equals to negative log of 20 ml times 0.02 molar calcium minus 2.5 ml times 0.04 molar EDTA times 1 mole of calcium over 1 mole of EDTA divided by 20 ml plus 2.5 ml. PCA is equals to 2.22. Recommendations. It is suggested that for future research, the brand of the soda used must be specified and the sample must be pure and free of contaminants. Gravimetric analysis and volumetric analysis are used to determine the calcium content of the soda sample. Extensive use of other quantitative method of analysis is suggested. Further analysis is suggested to determine the percent composition of other chemical compounds in the sample.